introduction. A very good morning, everyone. I'm Dr. Rahalya. I'm working as a Managed Fellow, and it's my absolute pleasure to welcome you all to the 8th webinar of our Managed Fisheries Innovation and Startup Hub Fortnightly Webinar Series. And since today is the World Fisheries Day, we pause for a moment to honor the spirit of our fisheries community, their hard work, resilience, and deep connection to the water. It is their courage and dedication that inspire us to promote innovation, sustainability, and a brighter blue future for the sector. And this makes today's session especially meaningful. And before we begin, I would like to give a short introduction about our Managed Fisheries Innovation Startup Hub. So MANAGE-FISHub is a newly established national level incubation and innovation hub at the Ministry of Agriculture Extension Management, Hyderabad, supported by the Department of Fisheries, Ministry of Fisheries, Animal Husbandry and Dairying, Government of India, and the Pradhan Mantri Matsya Sampada Yojana. So this hub is dedicated to transforming the fisheries and aquaculture sector through technology, entrepreneurship, and ecosystem development. And through this initiative, we offer a range of incubation, mentoring, and capacity building programs for the startups, empowering innovators to scale their ideas into successful ventures. This fishery incubation is indeed vast and promising. It provides a structured platform to nurture new ideas, promoting technology adoption, and strengthen linkage between the research, industry, and market and policy. It acts as a catalyst to transform innovative ideas into scalable, sustainable enterprises, enhancing the productivity, profitability, and livelihood across the fishery sectors. And through MANAGE-FISHub, we aim to connect startups, budding entrepreneurs, students, investors to build a vibrant and resilient fisheries innovation ecosystem in India. With this, let us begin today's session on startups in fisheries, a topic that beautifully aligns with the spirit and significance of World Fisheries Day. And without delay, I would like to start the session. To introduce our first speaker for the session, I would like to call Managing Intern Santosh.
Thank you, Rahalya ma'am. Good morning, everyone. Myself, Santosh Kumar from MANAGE-FISHub team. I am so privileged to introduce our first speaker of today's session, India's RAS revolutionist, Mr. Shaurya Agarwal, co-founder and CEO of Blue Wave Aquaculture Private Limited. Mr. Agarwal's childhood love towards fish grew into a fascinating entrepreneurial journey in the aquaculture sector. Along with his graduation in marine biology, he brings a strong global outlook through his background in international business at Bryant University and entrepreneurial leadership at Babson College. Guided by his passion, he co-founded Blue Wave Aquaculture to address the rising global protein needs while protecting the marine ecosystem from the pressures of overfishing. He has been instrumental in introducing the advanced RAS systems in India, producing the high-quality antibiotic-free trout in fully controlled environments. Today, Blue Wave Aquaculture stands as a model for the future of Indian aquaculture by creating livelihoods, strengthening supply chains, and providing that business growth and ecological stewardship can move forward together. With this brief introduction, I like to hand over the session to Mr. Shaurya Agarwal, sir. Over to you, sir.
Thank you so much for the warm introduction. Really appreciate it.
Trial.
So firstly, I would like to welcome all the participants and my fellow speakers. This presentation is about recirculating aquaculture systems and how Blue Wave is addressing recirculating systems in India. So next slide, please. Santosh, next slide, please. Yeah. So India is actually ready to farm fish on land using a smarter way. The question isn't can it work? The question actually is how should we make it work and make it work sustainably. RAS is very much a today's technology and not a technology for the future. Next slide. So this is the three main principles on which RAS system functions. You have to control the people, you have to control the system, you have to train the people, and you have to protect the margins. If you are successfully able to do these three things, your system will be profitable and will grow fish for harvests for you to sell. So this actually, all of you fisheries graduates should know this. This is actually what RAS is. RAS is a closed loop climate controlled system which has the capacity to reuse up to 99% of the water year round, and it has predictable yields. Uh, Compared to like a pond, it also gives you more control over the system, as the system is in a closed design and predator free environment. So technically, RAS is a living machine. Water moves through the mechanical filters that remove solids, then biological filters that convert ammonia into nitrates and nitrites through nitrification. Degassing columns strip out the CO2, oxygen units restore the O2 for saturation, and temperature controls the fish. Temperature control keeps the fish growing at optimum temperature. This allows us to raise the stocking density 5 to 10 times higher than traditional pond systems while reducing the water use up to 99%. They also allow us to cut disease exposure dramatically and bring feed conversion ratio below 1.2. This is how Norway grows salmon in snow, Singapore grows groupers in warehouses, and how India can grow trout, sea bass, and shrimp anywhere where power, water, and will exists. This is not the future, this is today. So now actually I want to highlight three ways why I believe RAS hasn't scaled in India. The three biggest issues is finance, operations, and sales. So finance, obviously upfront capex is very harsh on farmers. Land cost, system cost, over specified systems push the cost very high. Second is skill. Even after money is raised, operations stumble. Holding temperature, oxygen, and biofilter health is very difficult. Reading alarms, running backwashes, these simple tasks are what break down, which result in big losses. Third is sales. Even when the fish grow, profit leaks at the dock. There is no contracts, no delivery standards, no price discipline. Fish are sold like commodities and not like professional products. These are the three things we want to fix, and which I want to fix in this. I want to show you how we can fix in this presentation. Next. So firstly, we will talk about finance. Finance, we should always fund firstly what keeps our fish alive, which is the insulation, the oxygen, the biofilters, the alarms, and the monitoring. Everything else is secondary or can be used in cost cutting. We have the help of our government with Prime Minister Matsya Sampada Yojana. It also gives, you could also look at fisheries infrastructure development loan, which gives you a 3% interest subsidy. But the average cost of setting up a RAS is $26 per kilo in capex. For example, if you were growing 5 tons of fish using RAS technology, 5 into 1000 into 26 would be your cost of setting up the RAS. Anything which costs below this will not function and will not give you the right results for your fish. We will talk about how much Blue Wave is spending in the future slides, so you can get an idea of Indian RAS capex. This standard is more of an international standard. Next. So this is actually how we will fix operations. We use a simple 1-day daily card where morning DOPH checks are there, midday feeding and weight checks are there, evening alarm drills are there, nightly oxygen redundancy logs are there, weekly water exchange and biofilter inspection is scheduled, and we also respond to every alarm to see who acts, how it's done, and what was the result of him fixing that alarm. So simple routines, clear accountability is what is needed to run such a complex system. Now, if we come down to sales, we have to treat the fish, next slide please. Yeah, we have to treat the fish like a brand and not a commodity. We are using antibiotic free systems to produce high value species. So we have to display that to our consumers. We have to make sure that we give them all the options available, which is whole, head on gut, or fillet. And we also need to have reliable offtake agreements from reliable vendors, which is 3 to 4 months offtake weekly, which you can deliver with your farm. And we also have to use modern sales channels like setting up in grocery stores or setting up a distribution system using carts around the city. These are the ways we can, help in boosting the price per kilo we receive from the consumer. And now I would like to talk about how Blue Wave is doing and how Blue Wave is fixing this. Next slide, please. So Blue Wave's role is to provide end-to-end service to help farmers adopt RAS. Our economical model is designed in such a way that we have brought our capex down to $16 a kilo from $26 a kilo. Our OPEX for growing rainbow trout is about $3.3 a kilo, and we have a target EBITDA of 70%. This farm is scalable to 400 tons once we have a 100-ton farm operational. This is where we want to become India's benchmark for scalable, cost-efficient RAS trout farming, and place where farmers learn, trust, and also partner with. Next. So we would like to open our doors for all the farmers, all the students, for monthly demo days. For one, when we have a farmer come, we give them like a one page daily checklist reader which they can implement on their own farm. We also show them this different probes we installed in our system where we use to detect flow rates and DO, and we also give them an understanding of our sales channel and how we are training our sales channel. I always believe in opening the knowledge to everyone to build a better industry together, and that's why our doors are always open for anyone to come. Next slide, please. So the development payoff. This is where India will benefit from such developments. We will use smarter water resources. We will have a more reliable protein chain where we'll be supplying fresh antibiotic-free fish. We also will have skilled aquaculture specialists specializing in RAS and creating stable jobs and skilled labor in semi-urban region areas. After we prove a system, we also de-risk capital because the system is proven, so you can always make sure that you are putting your money in the right place and you will get what you deserve for your system. So India doesn't need perfection, it needs precision, and that's exactly where Blue Wave stands at. Next slide, please. So this is our vision ahead. India's relationship with food, water, and tech will completely change once we have a mass RAS adoption. We have to control the environment and the market will follow. And we are proving it here in Kolkata. Next slide, please. Thank you so much. If you have any questions, I will take it after all the presentations have concluded. I hope to make RAS work for every farmer in India. Thank you.
Thank you, Shaurya sir, for the insightful session. Your presentation clearly demonstrated how RAS can revolutionize like aquaculture by enabling the closed loop to control system that reuses up to 99% of water, ensuring sustainable and year-round fish production, and which is close to the urban market. It was really inspiring to learn about the practical challenges in scaling RAS, as it as finance and your operational discipline and sales, and how you are addressing them through the innovative business models, training, and open knowledge sharing. Your discussion on the development benefits, water conservation, and reliable protein supply, skill job creation, and de-risk capital truly showed us how RAS can transform India's aquaculture landscape sustainably. Thank you once again for sharing your expertise and inspiring us to see how precision, innovation, and discipline can make RAS a reality for every Indian farmer. So, before going to the second so if you have any doubts regarding this first session, you can keep in chat box, and also you can raise your hand. So the questions will be taken up after the second speaker presentation. And before going to the second speaker presentation, I would like to give some updates about the MANAGE-FISHub. So we have launched a MANAGE-FISHub incubation program, which is a national platform for fisheries startups and aspiring aquapreneurs to transform innovative ideas into successful startups. So through this, we are offering a 1-month mentoring come hands-on experience with leading fisheries and aquaculture startups. So you can gain practical exposure to the business models and strategic insights to the markets and value chains. And along with this, I want to give update about one more program, which is Aqua Eureka, which is a national level business challenge. And it provides a unique platform for the aspiring students, rural youth, and startups, entrepreneurs, and innovators to present their innovative ideas and the technological solution to the challenges prevalent in the fisheries sector. So the registration link for all these programs is also given in the chat box. You can register for it. Now, moving on to the next session, to introduce our second speaker, I would like to call our manager intern, Kalaivani.
Thank you, ma'am. Good morning, everyone. Myself, Kalaivani from the MANAGE-FISHub team. It's my great pleasure to introduce our second speaker, Mr. Amey Nayak, founder and CEO of Longshore Technology Private Limited, an innovative startup committed to sustainable value addition in the fishery sector. Mr. Amey Nayak is a marine geology graduate with over 2 years of professional experience in his family business and his passion for the potential of marine resources. He ventured into utilizing and transforming byproduct generated from fish processing centers. As the founder of Longshore Technologies Private Limited, he has been leading promising initiative that follows zero waste, environmentally responsible processes, ensuring complete utilization of raw material and contributing to circular fishery ecosystem. With his vision, Mr. Amey Nayak is contributing meaningfully to technological innovation and waste to wealth solution in the fishery sector. His work also extends beyond fisheries, reflecting his strong technological knowledge and foundation and innovative mindset. With this brief introduction, I would now like to hand over the session to you, sir. Thank you.
Yeah, thank you. Thank you so much for the introduction. I'll just try sharing, the PPT. Yeah. So yeah, is it audible? Is it visible now?
Yes, sir, it's visible. Kindly make slideshow, and then we can, we can go ahead.
Yeah. Okay. So, firstly, I mean, I guess the introduction was quite apt for our company initially. So let me quickly move on to the problem that we are trying to address. So, India, as we know, is the second largest exporter of shrimp in the world. We export to the tune of around 6 to 7 lakh tons of shrimps every year. But the thing is that with shrimps, there are a lot of different kinds of products that are made. So shrimp is generally deheaded, degutted. I mean, the audience over here might know much better than me what happens to the shrimp, but nearly 45 to 50% of the shrimp, which is processed, it goes into waste. What happens with the waste, or the problem that we saw is that the waste was either dumped somewhere into landfills. That was one. It was difficult to dispose it off in a very environmentally friendly manner. Moreover, the waste that was processed, it was either used into fish meal units or shrimp meal units, where they used to make very low value added products with it. Uh, the major challenge that we thought was sorting the waste, because when prawn is processed and the waste is thrown away, they treat it as waste. So the first thing that we tried to do was to separate the waste and get the cleaner or the usable waste out of the non-usable waste. Then what we did was we actually deployed a chemoenzymatic process to initially separate the proteins out from the shell and head waste. The protein that we separated out it was in the form of hydrolysates, and the general molecular weight of hydrolysates was less than 8 kDa, which is very suitable for aqua and pet feed. So we first standardized the protein in this case. So our overall chemical load for chitin and chitosan manufacturing would probably be lesser. Later on, what we found out was that India already had major chitin chitosan manufacturers who, worked on a very large scale. But the thing was, chitosan industry was highly chemical intensive. The process that we developed helped us minimize the use of chemicals into the manufacturing of chitin chitosan and produce a better quality chitosan than the general benchmark in India. So now we have two major products which we are selling. One is shrimp protein hydrolysate powder, which is derived from the head and shell, as well as chitosan, which is derived after the enzymatic protein hydrolysis of the shrimp head and shell powder. I am very happy to say that the chitosan that we are manufacturing has now met the international benchmark for chitosan, which comes from countries like North America as well as from China and Vietnam, and we have already started exports for this particular product. We are the only company in India who runs a biorefinery wherein we run on 80% less waste generation than your normal chitin or chitosan manufacturing units in a very sustainable and a profitable way. So let me just give you an idea of the key markets which chitin, chitosan, and protein hydrolysates have. So let us first move on to the chitosan market. So chitosan in industries is used as a major fuelant for industrial waste or industrial effluent, as well as a settling agent into proteins, which is used in brewing industry as well as into milk industry, the dairy industry. Then we have also developed a product from chitosan, which is a biostimulant. And we have demonstrated that this biostimulant has a better uh, pest controlling capacity and a higher growth capacity than your normal commercial biostimulants which you get. We have also started supplying chitosan as a raw material into cosmetics manufacturing units, mainly working on anti-aging, anti-acne products. We recently have collaborated with a UK-based company which is working on cancer medicines, mainly melanoma cancer, and they are currently using our chitosan as a substrate for the same. These are a few products of R&D which we are currently trying to develop. One is chitosan-based bandages for wound care. Then we are also making chitosan-based capsules which are used for weight loss purpose. Other than that, we are also trying to make a fabric out of chitosan, which will be an antibacterial and an antimicrobial inherent fabric. With regards to the protein hydrolysate, as I said, the protein hydrolysate has a very small molecular size. So we are incorporating it into feed. We are currently trying to push it into the feed industry. Also, we are trying to use it into agriculture as a source of nitrogen, which we have already done. Yeah, so these are few trials that we very initially did into agriculture, and these are some of the test reports that we got of our chitosan as well as protein as a plant growth promoter. These are a few samples of the bandages as I was speaking, and the chitosan based fibers that we are making for antibacterial, antimicrobial as well as wound care purposes. Our protein per se has a very low TBBN and a very high pepsin digestibility. In India, we initially did not receive much of interest, but now we have started receiving orders from countries like Thailand and Korea to incorporate this particular product into pig feed, fish feed, as well as shrimp feed. Yeah. So this is the current pilot plant where we are operating. It's a very small setup. However, we are working into putting this technology into a 21 feet container so that these containers can be deployed at a hyperlocal level into markets or fish vending near fish vending centers. And the shrimp waste that is generated over there will be processed then and there, and there'll be no issue or challenge of smell or any decomposition or any kind of other biosecurity hazard. Now, moving on to the last part. Yeah, sorry. What impact do we exactly have? So generally, when you speak of startups, you speak of impacts either financially or environmentally. So one is we are an environmentally or climatically regenerative startup. We also provide or we also help seafood exporters become competitive in terms of pricing. I'll just give you an example. So let us suppose you have around 1 kg of shrimp head and shell waste with you right now, and you are processing it into say shrimp meal, or you are just drying it and putting it into chicken feed. The maximum value that a company can extract out of it in the current scenario is around 25 to 26 rupees. However, if you work with our technology, if you deploy the chemoenzymatic process and you extract both the protein and the chitosan, you or any other company will be able to extract around 55 to 60 rupees of value from a single kg of shrimp head and shell waste, not the actual shrimp also. What this would do is this would give a better value to the exporters for their waste, and in turn the exporters would be able to give a better value for the shrimp, which would indirectly benefit the farmers also. uh, Moreover, as I told you, we work on very less effluent discharge, so we are helping currently in reducing the carbon footprint, as well as we are helping the society fulfill a few sustainable development goals as prescribed by the UN. And this particular thing, as I told you, it requires a lot of cleaning, sorting, and management of the waste. So this helps create employment at the farmer or the market or the peeling shed level also. So that is one thing that we are proud of, because fisheries, as we all know, nearly 2% of the Indian population is currently employed into fisheries. And if we are able to contribute our bit to create more employment, it is always a plus plus. So I guess that is pretty much it from my side. I would probably welcome any questions right now. Thank you.
Thank you, sir, for the impactful session on the innovative work being done by Longshore Technologies. And you clearly explained the challenges associated with the shrimp waste generated in the seafood sector and how Longshore is creating value from this waste through the biotechnology. Your explanation of the process right from the waste collection and extraction to the development of proteins and chitosan products was extremely informative, and it was really fascinating to learn about the wide range of applications of these products in agriculture, cosmetics, nutraceuticals, animal feed, and biodegradable materials, demonstrating how waste can be transformed to high value chain. And thank you once again for sharing your expertise and showing how biotechnology can drive sustainability in the fisheries sector. So the participants, if you have any questions regarding this session, you can keep in chat box, and also you can raise your hand, so the questions will be taken up now. So you can ask the questions regarding the both the speakers' presentation. So quickly, I'll take up the question. So there's a question from Nakirda Venu. Is the RAS system suitable for mural farming, and does Blue Wave engage in contract farming with the farmers? If yes, in which regions are you in operation? I think this question is to the first speaker.
Yes, so the answer to that question is pretty simple. Mural is a air-breathing fish, so it is not technically very suitable in RAS. With that being said, there is not enough research of mural in such systems to get a definite answer if it will be able to survive such systems or not. Right now, Blue Wave is concentrated on shrimp, uh, trout, and sea bass, which is Berumandi. But if there is a farmer who wants to engage in mural, we can do a small R&D farm for him to make sure that we also look at other localized species. For your answer of operations, Blue Wave operates pan India and has contract farmers in multiple areas of India where we are helping out build their farm.
Thank you, Shaurya, sir. So the participants, if you want to talk with the speakers also, you can raise your hands. Then I'm going to unmute you and you can directly speak with them. And then there is a question from Dinesh Babu from ICR CMFRA. Is this chitin or chitosan which is used for the sedimentation? Ami sir?
Yeah. So we generally use chitosan because chitin is a slightly, it's a very adamant kind of a polymer, but chitosan is very versatile. You can modify chitosan as per your substrate, and you can use either low molecular weight, medium molecular weight, or high molecular weight chitosan. We also have started making chitosan derivatives in the form of chitosan oligosaccharides and other quaternary chitosan salts, which can be easily applied for this particular application as they become water soluble. So the answer to your question per se is yes, we use chitosan for sedimentation.
Yeah, thank you. Yeah, there is a question from Ram. Why is high capex a barrier for RAS and how can strategic planning reduce it?
So this is a very good question from Ram. High capex is a huge barrier of RAS because a true RAS farm internationally, the industry average is $26 a kilo. As I gave this example in my presentation, a 5-ton farm will require a capex of 5 into 1000 into 26, which will be an international standard RAS farm. When Blue Wave brought RAS to India, we realized that our capex is way below 26 at $16 a kilo because of cost of labor, cost of land, and cost of materials being cheaper. Now, the future way of strategizing to even reduce it more is to stop our reliability on imports for RAS machinery and try to understand the system to its bone and build our own RAS system in India, which is not going to break on a farmer and kill its fish. So we need to make sure that the machine is bulletproof because 330 days a year it's switched on and it's operating. So it has to be a bulletproof machine to operate for such long periods of time and without any break. So that's the answer to Ram's question.
Thank you, sir, for the explanation. And then, so there's a question from Surya. What are the major challenges you face while extracting chitosan?
Yeah, and I'll probably take that. So with chitin, it's fairly easy, but when you move on to the deacetylation from chitin to chitosan, the first major challenge, if I start off with the process, is preparing your caustic soda solution. Because when you work on a very large scale, preparing a highly concentrated solution of caustic soda is quite risky and quite hazardous. So that is where we start off with. Other than that, initially we had challenges of either disposal or recycling of the spent caustic soda, not from the first batch, but the subsequent washing activity of chitosan that is done. But now we have devised a process where we recirculate it into our system so that nothing is set off as an effluent, everything is reused. So I guess, yeah, that is your answer. I guess there is another question regarding cost of extraction. So in our case, because we rely on a chemoenzymatic way, our cost of extraction of chitosan is marginally, not considerably higher than the conventional chitosan manufacturing process. So to be very specific and very direct, our cost of extraction of 1 kg chitosan is to the tune of around 800 to 850 rupees a kg in the flake form. If we probably powder it, there are some process losses that happen, and the cost increases to around 1050. I guess, yeah, there's one more. What type of raw material waste is commonly generated in shrimp processing units? Oh, that is fairly easy. So there are only two things. One is your shell and the other one is your head. If they are doing headless shell on, then you will get only the heads. If they are doing shellless head on, then you will get the head. So yeah, I guess the shell and head are the only two raw material or waste that is generated. Other is your liquid or the the ammonia kind of liquid that is generated when shrimps are kept for a long time. But that is of currently no use to us as it has nothing except very low quantities of ammonia. So yeah, that is it.
Yeah, Amay, can you hear me?
Yeah,
Oh yes,
Anandan, you
sir.
are audible.
Yeah, thank you. And then I'm happy to listen to your presentation, and then certainly no, glad that such startups are coming to recycle the waste and create wealth. I just want to learn about like how are you sourcing your raw material at present? Are you sourcing directly from the markets, or you are having some vendors who collect and supply you?
Okay. So what we have done is we have set up our pilot plant in a cluster which consists of seafood processing units. So we are in very close proximity to the waste generation point. The other thing what we have done is we have collaborated with seafood exporters. Currently, we are not picking up waste directly from the market because sorting waste from the market is a different challenge altogether. We are taking waste from the peeling units of seafood exporters, and that waste, I mean, we have devised a process flow and a logistics this thing in such a way that the waste reaches within 3 hours of peeling from any peeling shed that surrounds us. If the waste is not that much, then we keep it under iced condition in a cold storage so that it does not go bad. And then whenever we have the desired amount of waste with us, we start processing. So that helps us, maintain our quality basically of the protein. With chitin, chitosan, it's still okay. But when you talk about protein, you need a waste which is not too bad.
Yes, thank you. But that how competitive are you in sourcing this product in relation to other conventional manufacturers of chitin chitosan, and also that the lot of now what we call trash fish is being caught and then directly getting supplied to fish meal plants, right?
Right.
So I hear from you saying that that there is a lot of value can be extracted from even such shrimp that is being caught directly and non-pinnate shrimps that might be going into the fish meat plant. So
Correct.
whether you have the kind of setup that you have a scope to process that kind of shrimp, non-pinnate shrimp.
So in the current pilot plant, we do not, but we have already done R&D and we have established processes where we can use the non-pinnate shrimps and process them into valuable products. So I'll just give you an example, not with us, but there is a company in Vietnam which we had visited long back when we were just starting off with this particular project. They had a process wherein they used to make 80 different products just from shrimp waste. And nearly, I'll tell you, around 60 to 70% of the products were used for human consumption. So I guess if you have the right infrastructure for R&D and the right kind of capital to convert it into a commercial process, the scope and possibilities of processing not only pinnate, non-pinnate shrimps, but also any other trash fish are endless. But here I would like to say by trash fish, I don't mean juveniles. We are strictly against processing any juveniles that are caught. So we discourage that.
Thank you.
Okay.
But the last question that are you, I hear you are going to Vietnam or tying up with the UK-based R&D labs and all. So
Yeah.
aren't you collaborating with any Indian ICR or other institutions for your work?
Oh, we have already collaborated with ICR CIFT as well as your institute also, sir. We are currently working with ICR CIFT Warsaw to develop a few products with the shrimp protein hydrolyzed and basically stabilize it furthermore to enhance the shelf life of the protein hydrolyzed. So, in fact, I'd like to tell you that this process or the initial R&D started off with a collaboration between my company, ICR CMFRI, and ICR CIFT.
Okay, thank you. Yeah.
Yeah. Thank you, sir. We'll take one question from Raju. How does Blue Wave Aquaculture aim to make RAS scalable and cost efficient in India? Mention any three metrics, capex, opex, redundant systems.
So this is actually to answer this question, I'd like to highlight a little bit of what RAS today is in India. RAS is a unreliable, almost like a bad word in the aquaculture world, where farmers are installing systems and failing and not being able to harvest any fish because the system breaks down, the ammonia increases, the drops, the fish die, and so high mortality, less knowledge, and bad systems are what's plaguing India RAS today. The way I see RAS being adopted in a large scale and cost effective way is first to understand how true RAS actually works. And that's how in Blue Wave Aquaculture's trout farm, we are planning to do that, where we have an international standard IoT enabled self-grading system where, a farmer does not need to rely on other metrics apart from what he's getting through the probes and to make informed decisions about their farm. Same with OPEX. We as Indians have a huge advantage compared to the rest of the world. As I mentioned, the rest of the world's capex is $26. Our capex is $16. Our rest of the world OPEX is about $8. Our OPEX is about $3.3. So there's a huge opportunity in India for already researched RAS species to be cultured in RAS and to stay away from species who we don't know much about in such systems. To do that, we need to first research with those species in these systems to make sure we can do commercial farming of those species.
Yeah. Followed by one more question from Sitra. Is asking what long-term developmental benefits can India achieve by adapting RAS at scale, be it water security, jobs, stable protein supply.
So this actually is a very big point. There's a lot of development benefits. Firstly, water security. Water is a very finite resource, and the way we are abusing water today in today's India is going to lead in a very bad way in the coming future. So water security definitely. High skilled jobs, high paying jobs, because a RAS farm employee earns quite a lot compared to a traditional farm employee. So high paying jobs, stable protein supply for the growing population of India. Not just that, it also empowers farmers. Year round production will get farmers 2 harvests a year instead of 1 harvest a year, which will increase a farmer's earning. It's just that to make sure the farmer is being able to adopt RAS and to use RAS in a very stable way is the challenge, which we are addressing.
Okay, sir. And then, so Vaishran, this question is to Emi, sir. So you only stuck to shrimp or any other sources? And then followed by one more question. What steps are involved in converting shrimp waste into useful products?
So I guess I'll answer Vaishravan's question first. So yes, we are stuck to shrimp, and currently we're not looking at any other sources because our plate is already full, and the possibilities with shrimps that we have discovered till now are quite huge. There is a lot of work to be done. So I suppose till the time we extract 100% value out of the shrimp, we would not be probably moving on to any other sources right now. So that is it about that question. And with Raghu's question, see, by useful products, I mean, for us currently, the useful products are protein hydrolysates and chitin as well as chitosan. So I already explained the steps that are involved, but if you are looking at any product that you want to make from shrimps or shrimp waste per se, the first thing that you do is ensure that the shrimps come from a legitimate source. They are handled properly and they are cleaned thoroughly before processing into any product that you want. So you can go for there are products coming up which are just freeze dried or deep fried shrimp heads with some umami flavor to it. There are a few companies who are doing it. I just saw. There are shrimp pastes that are made from shrimp heads, and they are actually sold commercially in countries like Vietnam and Japan. There is shrimp oil that you can make, but it all depends on having very good quality of waste. I mean, it's an irony having waste of good quality, but that's a mandate.
Yeah. So there is one more question from Karuna. How does processing at the source benefit seafood industries?
So processing at a source ensures that the raw material is fresh. Processing at the source ensure that you have control over everything that happens to the waste or seafood, you know, from point zero. So that gives you a better hand at having good quality and better products. So I guess that is the main part.
Yeah. So that's all about today's session. I think there are no more questions. So thank you, participants, for all your questions. And due to time constraint, I think still I don't think no more questions. But okay. However, still, if you have any doubts regarding these two sessions, you can reach still. You can talk with the speakers. The contact details have shared in the chat box. And also, if you miss any part of today's webinar, and if you want to rewatch this webinar, the YouTube link to watch the full session is also provided in the chat box. And to stay updated on upcoming events and programs and exciting opportunities from the MANAGE-FISHub, be sure to follow us on our social media platforms. And with MANAGE-FISHub, we are opening doors to various programs from business incubation and expert mentorship to funding access. And along with this, I have one more update along with the Managed Fish Incubation Program and also the Aqua Eureka. And along with this, we are organizing the Managed FISHub 22 days mentoring programs for aspiring aquapreneurs and startups to guide the aspiring aquapreneurs and professionals in idea generations, business validation, and navigating the fisheries startup ecosystem. And along with this, as we celebrate World Fisheries Day today, it is inspiring to see many participants who are committed to strengthening these fisheries and aquaculture sectors. Your passion and curiosity truly reflect the spirit of this day. And on that note, I would like to express my sincere gratitude to our speakers, Shaurya sir and Ami sir, for sharing your valuable insights and experience with us. And a heartfelt thanks to all the participants for your engagement and thoughtful questions. And also, I would like to thank our director, Dr. Saranandra sir, for his vision and constant motivation to nurture aspiring aquapreneurs. And my thanks to the entire team for efforts in organizing the today's session so seamlessly. Finally, don't forget to give the feedback of this webinar. The feedback link is also shared in the chat box, and also do register for the upcoming webinar. Thank you once again and see you all in the next webinar. Thank you, Ami sir and Shaurya sir.
Thank you so much for having us here.
Thank you, Ami and
Bye.
Saurya. Thank you very much.
Thank you so much. It was great speaking to all of you and to address all the students. If any students have any questions, they can directly email me or have sent to you guys, and you guys can send it over to me.
Certainly.
Yeah, thank you. Thank you, participants.